Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Today's class we are going to discuss fluid mechanics. Okay, fluid mechanics especially for civil engineering students. So we are going to discuss previous year's questions, how fluid mechanics, how questions can be asked from fluid mechanics. It's just an idea for the students for preparing their semester examinations, because at this stage students will be completing their syllabus, they will be completing their revision. So if we get some idea of how a question can be asked in different ways, so it will be somewhat helpful for preparing for the upcoming semester examinations. Okay, so now we'll start discussing. So actually it is part A and part B is there for this R18. Okay, so but for this now upcoming semester exam, you are supposed to have only single format, no part A and no part B. You are going to get 8 questions. From these 8 questions you are supposed to write any 5 of your own choice, right? Now we'll start discussing how the pressure can be measured by a manometer. What is flow net? What are practical applications of Bernoullis equation? What is an equivalent pipe? What do you mean by laminar sublayer? Define the term fluid. Distinguish between liquid and gas. Describe assumptions and limitations of Bernoullis theorem. Explain the working principle of an orifice meter. Define the term Wiener contract. Illustrate the examples of formation of boundary layer in day-to-day life. Okay, so this is part E. Derive expression for total pressure and center of pressure for a vertically immersed surface. A 18 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.50 centimeter. Both cylinders are 28 centimeter high. The space between the cylinders is filled with a liquid whose viscosity is unknown. If a torque of 12.0 Newton meter is required to rotate the inner cylinder at 120 rpm, determine the viscosity of the fluid. What is viscosity? Differentiate clearly between dynamic viscosity and kinetic viscosity. A wooden block 4 meter by 1.2 meter by 0.5 meter is floating in water. Its specific gravity is 0.76. Find the volume of concrete of specific gravity 2.5 that may be placed on the block, which will immerse the block completely in water. Block and concrete in water. Write the expression for the resulting force acting between two sections of the pipe in terms of discharge using impulse momentum principle. The stream function for a dimensional flow is given by 2x. Stream function is equal to 2x. Calculate the resultant velocity at p 3, 4, also the velocity potential function. Okay. Derive the Bernoullis equation from Euler's equation of motion. Write application of Bernoullis theorem for steady flow of an incompressible fluid. The water is flowing through a pipe having diameter 20 cm and 10 cm at sections 1 and 2 respectively. The rate of flow through pipe is 3.5 liters per second. This section 1 is 6 meter above datum and section 2 is 4 meter above datum. If the pressure at section 1 is 39.24 Newton per centimeter square, find the intensity of pressure at section 2. Okay, now we will some more questions are there. Okay, what are advantages of a triangular notch over a rectangular notch? A 400 by 200 mm venturi meter is provided in a vertical pipe line carrying oil of relative density 0.9. The flow being upwards, the difference in elevation of the throat section and entrance section of the venturi meter is 30 cm. The differential U2 mercury manometer shows a gauge deflection of 250 mm. Calculate the discharge of oil if the coefficient of meter is 0.98. Derive an expression for the time required to empty a tank with a rectangular notch. The diameter of pipe bend is 0.4 meter at inlet and 0.2 meter at outlet, and the flow is turned through 120 degrees in a vertical plane. The axis at inlet is horizontal and the center of the outlet section is 1 meter below the center of inlet section. The total volume of fluid contained in the bend is 0.09 meter cube. Neglecting friction, calculate the magnitude and direction of force exerted on the bend by the water flowing through it at 0.4 meter cube per second when the inlet pressure is 140 kilonewton per meter square. Derive an expression for the power transmission through the pipes. Find also the condition for maximum transmission of power. The difference in water surface levels in two tanks which are connected by three pipes in series of lengths 300 meter, 170 meter and 210 meter and of diameters 300 mm, 200 mm and 400 mm respectively is 12 meter. Determine the rate of flow of water if coefficient of friction are 0.005, 0.0052 and 0.0048 respectively, considering minor losses, also neglecting minor losses. What are the factors influencing the frictional loss in pipe flow? A pipeline of length 2000 meter is used for power transmission. If 110.3625 kilowatt power is to be transmitted through the pipe in which water having a pressure of 490.5 Newton per centimeter square at the inlet is flowing, find the diameter of the pipe and efficiency of transmission. If the pressure drop over the length of pipe is 98.1 Newton per centimeter square, take F is equal to 0.0065. Distinguish between local coefficient of drag and average coefficient of drag. In a circular pipe of diameter 100 mm, a fluid of viscosity 7 Poisson specific gravity 1:3 is flowing. If the maximum shear stress at the wall of pipe is 196.2 Newton per meter square, find the pressure gradient, the average velocity. Explain the characteristics of laminar and turbulent boundary layer. Find the displacement thickness, the momentum thickness and energy thickness for the velocity distribution in the boundary layer given by u is equal to y by delta, where u is the velocity at a distance y from the plate and u is equal to capital U at y is equal to delta, while delta is boundary layer thickness. Also calculate the value of delta by theta. Okay, so that's all friends for today's class. I think these are the questions which was asked in previous year. Okay, so I think today's class will be helpful for your exam, upcoming semester exam preparation. Okay, if you need any additional information, okay, if you are having any doubts regarding this fluid mechanics, please post in the comments box. I will give you a reply. If you are not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends regarding the class work going on in our channel. Okay, so thank you very much. Thank you for watching.